Notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos. These first three sections here, 1, 2, and 3. All 51 of these videos have been published in their entirety on YouTube. Section 4, measurement. All 17 of these videos have been completed. 5 have been published in their entirety on YouTube. Section 5, statistics. All 18 of these videos have been completed. 5 have been published in their entirety on YouTube. Section 6, algebra. This is where we are right now. This is the 19th of 22 videos. After that, we still have to do section 7, relations, functions, and graphs. Should complete that by October 2025, followed by section 8, geometry and trigonometry. Should finish that by November 2025. And finally, section 9, vectors and matrices, to be completed by the end of this year, 2025. Please note this disclaimer down here. This schedule is just a projection and is not to be interpreted as a contract with anybody. I will quickly scroll through most of the typical introduction since this video is quite intense. So as I said, I will quickly scroll through most of this introduction that you have seen already. One change here. This is the updated homepage for Math Portal. That is the same RSC student. This URL will lead you to this web page. So we finish objective 17. We are now at objective 18, which is actually video 19 in this section. As I said, we finish up to video 18. These are published in their entirety on YouTube. Those 6 and these others are published only partially. We are now at objective 18, video 19, and when this is finished, it will only be published partially. So objective 18 says, solve a pair of equations in 2 variables when one equation is quadratic or nonlinear and the other is linear. Note that this objective does not require you to derive those equations from word problems, although by now you can do that. Your syllabus defines quadratic function as a function given by a polynomial of degree 2. That's from page 65 on the syllabus. And a linear expression where x has a variable of power 1, no more, and a and b are constants. That's from page 63. A simpler way of saying that is a quadratic equation is one in which the highest index is 2, like 2y squared or y is equal to 3x squared. Notice there is no higher index here. B squared is equal to 4b, and p is equal to 2q squared plus 3q. Now, if you don't see an index there, it means a 1 is there. So the highest index is 2. That's a quadratic equation. So we have 4 of them here. If we were to plot one of these graphs, say this second one here, y is equal to 3x squared minus 6x minus 5, what do we get on the graph? Well, first of all, we have to get the points to plot. So we will take typical values for x, substitute them in this equation. We will get the y values, plot a graph, and the graph looks like this here on the right. Let's take a closer look at that. If we let y equal 0, then what is x? You come down here to where y is 0, then what is x? Well, obviously, x would be at that point where the graph touches the x-axis, and this point where the curve touches the x-axis. Remember, y is 0. So it is at the point where x is. Now, a linear equation is one in which its highest index is 1. Like what you have here, 3y to the first power, it's not so stated, y to the first power times 2x to the first power, 4b to the first power, p to the first power is equal to 5q to the first power. Notice the highest index is 1 for the variable. Now, if we plot one of these graphs, say the second one, y is equal to 2x plus 5, this one here. Well, of course, we'll have to get the points to plot first of all. So we take points from -5 to 6 for values of x. We get the corresponding values of y. We plot that on a graph, and we get this. Notice a straight line, linear. So that's our linear graph. If we let y equal 0, then what is x? You have to come down this y-axis here to 0, and what is x? Well, obviously, x is that value there, whatever that is. And of course, if you let x equal 0, so now you go across the x-axis, and you come to its 0 point, go up here, what is this? Well, as you can see, if you let x equal to 0, then the answer is that y is equal to +5, as you can clearly see at this point here. Now, if we put a quadratic equation and a linear equation on the same graph, what do we get? This is what we are trying to solve in this objective. So, quadratic plus linear. Now, this is the same quadratic equation we were looking at just now, and the same linear equation we were looking at just now. We put those two on a single graph, we get this. This one, by now you know that that is the quadratic equation graph. This is the linear. In this case, the linear graph intersects the curved one at 2 points. Those 2 points are the solution to these equations. In other words, you have 2 solutions. One is here, you have an x value and a y value at this point, and you have another one here. Both of them will work in both equations. But we need to learn to solve these equations without the excitement of graphs, as you see over here on the right. So we will calculate this one, and then we will do 4 more like this for the rest of this objective. And by then, you should know how to do this. If you find this video useful and interesting, please like and share. You may also consider subscribing to this channel. So example 1, this is the one we just did by graph. But now we are actually going to calculate it. Now you can see clearly that y is equal to this expression here, and y is also equal to that expression here. Therefore, this first expression is equal to this second one. So you set it up like that. 3x squared minus 6x minus 5 is equal to 2x plus 5. Since both of them are equal to y, then they are equal to each other. So now we can combine this, move these two expressions from the right-hand side to the left-hand side, and then we simplify that. 3x squared, that negative 6x plus this negative 2x would give us minus 8x, and 5 minus 5 minus 5 would give us negative 10. And of course, we have 0 on this side. So now we have a single quadratic equation without y. Now, this equation cannot be factorized since there are no two whole numbers that have a product of negative 30. Remember, 3 times negative 10 would give us negative 30. So we don't have any two whole numbers that have a product of negative 30 and at the same time have a sum of negative 8, which means that we cannot factorize that expression. So we will use the formula. By now you are well acquainted with how to do this. You substitute b and a and c and so on. And notice b is negative 8. If you substitute negative 8 and there is already a negative in front here, that will eventually work out to be positive and so on. When we work out this part here under the square root sign, we get 184. We still have to find the square root of that. So we have 8 plus or minus 13.56 over 6. And so if we plus here, we divide by 6, subtract, we divide by 6. And we get these two answers for x. But then we will substitute that in the equation to get the value for y. Now substituting 3.59 for x in this second equation here, you can use either equation, it makes no difference. We get that y is equal to 12.18. So the first point is 3.59 and 12.18. And then when we use this other value here for x, we substitute that in the other equation. As I said, it doesn't matter which equation you use now. And you work that out, you get 3.17. So the other solution is negative 0.93 and 3.17. So these are our answers. Recall from the graph, we got the solutions, but they were difficult to read. Now let's put these calculated values in there. And so you find that this here is one of the solutions, and this is the other one, but they would be difficult to read off a graph. So let's take a closer look, keeping in mind that the graph will not be as accurate as the calculation. This is what it looks like. It's difficult to read that point as 3.59 and 12.18, and this one here as negative 0.93 and 3.17. Now, if you have to do this kind of graph work, you know what it entails. However, for the other 4 examples in this presentation for this objective, we are required to do only the calculations. So that is what we will do.